This is Mohan Kelkar. This is the fourth video of my Energy Reality series. Let me first summarize some of the conclusions about this particular presentation. Most of the other sources of energy we're going to talk about, which are used to produce useful work, cannot be scaled very easily like fossil fuels. Renewable sources such as wind and hydro are known to humans for thousands of years, but we displace them with fossil fuel as soon as fossil fuels become available. Certain energy sources, such as biomass, can be used in excessive amounts. When there is an excessive demand for any energy source, that source will disappear faster than it can be reproduced, and that has happened to biomass before. Let me acknowledge some of the books I have used to prepare this presentation. There's a book by Tester et al. Called Sustainable Energy, and there are three books by Václav Smil: Energy Transitions, Energy Myth and Realities, and Energy and Civilization, A History. I strongly recommend that you read the books if you want to learn more details about this presentation. We discussed the importance of humans in providing the energy source in the previous video. Humans also used draft animals to produce useful work, such as horses, oxen, buffaloes, donkeys, mules, and camels. Humans also use water as a resource for energy, as well as wind, and finally, the biomass. So let us first discuss the use of draft animals. Humans started drafting domestic animals over 5,000 years ago, and those animals were primarily used for transportation and plowing or farming. The energy efficiency for most of these draft animals were in the range of 12 to 8%. That is, if they consume certain amount of energy, about 12 to 18% of the energy was used for useful work. With better breeding and feeding, over 5,000 years, the draft animal's ability to do useful work improved over time. On the right hand side, you will see a comparison between how much work humans can do versus the draft animals. We already discussed that humans can do on an average 700 kilocalories of work per day. Horses can do 8 times as much work as humans. Oxen can do about 4 times as much work as human. Donkeys and mules about 1.5 times human, and buffaloes can do 3 times as much work as humans. When you look at the comparison between humans and other animals, you can easily see that it is very difficult to scale that type of work significantly beyond what's available based on these animals. Just for further amplification of that particular idea, I'm comparing 1 gallon of gasoline versus draft animals. We can all imagine that 1 gallon of gasoline can take people in a standard car for about 25 miles or 40 kilometers in an hour. How many humans, horses, oxen, donkeys, or buffaloes we need to carry out the same amount of work in 1 hour? You'll see that about 170 humans are needed to do the same work, about 23 horses, about 35 oxen, about 120 donkeys, and about 45 buffaloes will be needed to do the same amount of work. Let's consider a thought experiment and we hire humans to do that work. If you pay $15 an hour for each individual, it will cost us $2,550 to hire humans to do the same amount of work as 1 gallon of gasoline. The cost of 1 gallon of gasoline is about $3.50. If we pay 50 cents a mile, we will have to pay $12.50 to travel 25 miles. Comparing these numbers, you can easily see that the cost of fossil fuels to do useful work is significantly lower, orders of magnitude lower, than the cost of doing the same work either by using humans or animal labor. Humans also use water mills as a way to do the works. The earliest use of hydropower using water mills started about 2000 years ago. And hydropower was used primarily for grain milling, but also used for sawing, pressing, cutting, and grinding. Typical hydropower mill could provide as much useful work as about 40 to 70 humans. The power provided by a mill was still a lot smaller than an economy car with a small engine. Windmills started in utilization about 1000 years ago, and they were also primarily used for grinding, crushing, sawing, and especially in Netherlands to drain water. They could replace between 40 to 100 humans based on typical useful work. Unlike water wheels, which could be run continuously, windmills only ran intermittently because of the intermittent nature of the wind. From these data, you could clearly see that the scale up of windmills or water mills was not that simple. Biomass was also used as part of the energy source. Hardwood, softwood, plants, grasses, crop residues, and animal dungs were commonly used as a source of energy which could produce useful work. The typical carbon to hydrogen molar ratio for wood is approximately 10 to 1, and in terms of weight percentage, carbon is 99% and hydrogen is 1%. The energy content of biomass is also smaller, about 2000 kilocalories per pound, lower than coal, which is about 3300 kilocalories per pound, oil, which is about 4800 kilocalories per pound, or gas, which is 6000 kilocalories per pound. Biomass also can contain substantial amount of moisture or water, somewhere in the range of 20 to 40%, which can reduce its energy content. The one disadvantage biomass has compared to fossil fuel is that biomass are dispersed and require significant amount of effort to gather and transport it. In the historical sense, when there was excessive use of biomass, we ran out of biomass. And there are two examples of that in the history. In 19th century, in some parts of the United States, we ran out of biomass because we used too much of it. And the 18th century United Kingdom, as wood was used to produce charcoal, we also deforested significant amount of land. So biomass, if it could not be produced fast, then there is always a possibility that significant deforestation could be created in the world. So just to summarize the history of other fuels, humans have used many other resources of energy to supplement their energy needs that include draft animals, hydropower, wind power, and biomass. The percentage contribution of these fuels has diminished significantly in 20th century as fossil fuels have become readily available. The only exception to that rule is biomass. Draft animals are rarely used for useful work except in some developing countries. Hydropower does provide with water turbines. Electricity in many countries, about 17% of the electricity in the world. And wind turbines provide about 6% of the electricity in the world. Biomass are still common source of energy in many developing and poor countries, and they provide about 10% of the world's energy source. If you look at the energy distribution today, you find that in 2019, about 3,500 New York City's worth of energy is used in the world today, out of which 2,750 is provided by coal, oil, and gas. Biomass has maintained a relatively constant percentage of 10% of the energy source. We can think about biomass as fossil fuel light, except that it is not subjected to pressure, temperature, and time changes. But biomass is useful and it is still widely used by poor countries. The contribution of solar, wind, and renewables is less than 4% in the world today. Fossil fuels dominate, and why they dominate, and what are their characteristics which make it possible to use fossil fuels efficiently, will be the subject of my next video series. Thank you very much for watching it. If you like the presentation, please subscribe to my channel.